Unlike some other examples, here we are not provided with information about what X bar and S are equal to. We're just given the raw data. And so whether using a calculator or StatCrunch if it's available, or Excel, we're going to have to find the sample mean and the sample standard deviation. Now, it doesn't make a difference when it comes to the mean, how you do this, because you just add up the scores and divide by how many scores there are, whether it's a population mean or a sample mean. So it's going to open up in just a minute here. But there are differences in how we compute the sample standard deviation versus a population standard deviation. But since I'm using Excel, not particularly worried about that. So we need the average of the scores from column A, row 1 through column A, row 12. And then when it comes to the standard deviation, STDEV dot S from A1 to A12. Notice the equal sign I put in front of average and in front of STDEV. Now, I'm not sure how far they want this out. So if I go to the top of the column and move that part to the right, it'll show me more digits. So let's go back. Okay, so the point estimate for the population mean, in other words, X bar, I was finding 5.04. Oh, 5.04. Okay. And then the standard deviation was 0.4150, et cetera, et cetera, et cetera. Let's see if they want that rounded or not. 0.41507, 41507. Okay, they're not asking for it yet. Construct a 95% confidence interval. Now we will need to use the standard deviation shortly. 95% confidence interval. Then you would subtract the 95 from 100. Divide that by 2. Convert that to from a percent. That's 2.5% that needs to be in the right-hand tail when we look at table 7. And so that's 0.025. The other thing that we need when looking at the table, that sample size was 12. So we have 11 degrees of freedom. 11 degrees of freedom, and we're looking at the 0.025 column. T sub alpha over 2, or T sub 0.025, is going to be 2.201 right here. 2.201. So I'm going to get my lower bound by subtracting X bar minus 2.201 for the t-value times the sample standard deviation divided by the square roots of the sample size. Notice that there were 11 degrees of freedom. That doesn't change the sample size. Degrees of freedom is just telling us what row to look at, whereas the formula for the lower and upper bound of your confidence interval just has n. So there's our lower bound. The upper bound, I'm going to switch that to addition. So we have, let's see here, 2.201 times our standard deviation divided by our sample size. And I'm not doing any rounding here. If they want rounding, I'm going to do that to those answers there that are going out as far as I can see. So they want this to the 2 decimal places. Again, our lower bound was 4.776. So that's going to round up to 4.708, whereas the upper bound will round down to 5.30. 4.78 and 5.30. They're adding in here something about a correct interpretation. So that correct interpretation is, if we were to go back to where they gathered that rain and measured the pH level over and over and over again, get simple random samples of size 12, get every simple sample, random sample of size 12. That's weird. Then quite like how that's worded, but okay. What I think should be said is that X bar, short of rounding, should be halfway in between here. X bar should always be in your confidence interval. What we don't know is if mu is in there. We have 95% confidence that it is. So I would be saying with getting all the simple random samples of the same size and getting the confidence interval for each one of them, I would say 95% of those have mu in between the lower and upper bound for those particular intervals. But I'm not seeing that exact wording stated here. Maybe it's part A then. Okay. So let's go up here. I was looking for a longer interpretation than what they were looking for. They're just talking about the 95% confidence. Okay, sorry about that. Increase the confidence level. Increasing the confidence level, we look at the table here. Where's that? Now that we have 1%, take that away. Sorry, take 100 minus 99. That's going to be 1%. Divide that by 2. You get 0.5%, which as a decimal is 0.05. 0.005. So right here, we're still dealing with the sample size of 12. Okay. So 11 degrees of freedom. Look at what happens along this row or any row as you move further to the right. An increasing confidence level is going to leave less area outside, less area in the right-hand tail specifically. And so the t-score that cuts that off, you know, where it starts that at, is going to be higher if you want a higher confidence level. That higher t-value is going to give us a larger margin of error. It's going to make the confidence interval wider. So 11 degrees of freedom and half of 1% is going to be 0.005. So our t value is 3.106. And so I'm going to go back here and change. Let's just copy these. Actually, before we do that, I'm going to fix in place that I was going back to row 13 there and row 14 there. Same deal here. Putting these dollar signs for some reason on Microsoft fixes rows. Okay, so what I want to do is change. Darn it. I want to change the 2.201 to the 0.201 to the 3.106. All right. So fix the row, but I didn't fix the column. Darn it. Sorry, a little bit tired at the moment. 3.106. Yes, 3.106. Okay. 3.106, 3.106, 3.106. Again, I need that from column A. And then switch it to addition. So notice how this lower bound is less than this one, and this upper bound is higher than that one. As I said, the higher confidence level is giving us a larger t. That gives us a larger margin of error. It spreads the confidence interval out wider. And I'll bet they want this rounded to the hundreds place, 2 places again. If that's the case, that's going to be 4.67 and 5.41. 4.67 and 5.41. The option I'm putting that under is that we have 99% confidence that mu would be between these two values. That's a short interpretation of what that confidence interval means. You talk about a longer version of an interpretation, then you start talking about repeated samples. But that would be about how many of the confidence intervals capture mu. Not this particular one. So as the level of confidence changed, as it increased, the width of the interval increased. This makes sense because since the margin of error is increased as well. That was because t was larger.